Welcome to this explainer. Today we're jumping straight into the hidden architecture of numbers, how the place value system actually works. You know, we often think of math as just this crazy race to the right answer, but true mathematical fluency, it isn't about rote memorization. It's about really understanding the foundational why behind every single digit. By the end of this, you'll see that understanding this secret architecture literally unlocks almost everything else we do in math.
So let's look carefully at just a single digit. Take a 7, for instance. It's got a very simple, straightforward face value, right? If you have 7 apples, you can physically point to each one. It's a totally concrete, isolated amount.
But throw a 0 on the end, and ask yourself, has the number gotten bigger or smaller? Well, that underlying value instantly scales up, right? It becomes 70. Yet, if you notice, the actual shape of the 7 itself hasn't changed one bit.
Now shift that exact same symbol one more spot to the left, and boom, it becomes 10 times larger. Now it's worth 700. The digit is still just a 7, but its new position has completely rewritten its reality.
Okay, let's dive into this, because this is the core concept of place value. It sounds like a super basic, dry math term, but it's actually this incredibly elegant, simple rule. A number's physical position dictates its actual worth. Where a number sits tells us exactly how much it is valued at. To visualize this, I like to think of our number system as a giant row of houses. Every digit gets its own house, starting with the ons on the far right. But the second a digit packs up its bags and moves just one house to the left, its value multiplies by 10. It scales all the way up into the millions.
Let's read a number aloud together. 4,376. Now focus on that very first digit. It is so easy to look at that symbol and just think, oh, that's just a 4. But is it simply worth 4? We have to look at the house it occupies.
Breaking down the architecture here, that 4 actually lives in the thousands house, making it worth 4,000. The 3 acts as 300, the 7 is 70, and the 6 is just 6. Think about it. If you were to cover up that 4, the number doesn't just shrink by 4 tiny units, it loses 4,000. Let's step it up to a much larger number. Read this one with me, 28,415. Glancing at these individual digits, which one do you think actually holds the most weight in this entire sequence?
Now, what's really interesting about this is that your eyes might naturally gravitate straight toward the 8, simply because 8 has a larger face value than 2. But place value completely changes the game. Because the 2 sits further to the left in the 10,000s house, it represents 20,000. It easily beats out the 8,000. Position absolutely trumps face value.
All right, here we have a massive number, 703,842. I want you to direct your attention specifically to that 0 sitting right there in the middle. It is such a fascinating digit.
You might ask, is 0 actually worth anything? Well, on its own, no, it isn't. But in the place value system, it's doing a totally critical structural job. It is literally holding the place. Think of it as a structural pillar in our row of houses. Without that 0 sitting in the 10,000s column, the 7 would slide over, every other digit would shift along with it, and the entire value of the number would collapse and change completely.
And you know, this structural understanding is also the absolute secret to comparing numbers. When two numbers look nearly identical, we just process them sequentially from left to right. The 4s match, the 5s match. But look at the hundreds column. The 2 beats the 1. The second we find a larger digit in that same position, the comparison is totally settled.
Let's shift gears for a second and imagine this number, 5,476, is climbing. If I add exactly 10 to this value, which specific digit is going to change?
Yep, exactly one digit. Only the tens column shifts, moving from a 7 up to an 8. The thousands, the hundreds, and the ones remain absolutely untouched. Because we only added a 10, only the house where the tens live gets the upgrade.
Understanding these houses also completely unlocks the mechanics of rounding. You know, finding a number that is close to the original but just way easier to manipulate. Say we want to round 4,362 to the nearest 100. Our target is the 3, but the real key to rounding always lies with the neighbor directly to its right, the 6.
And here is literally the only rule you ever need to remember for rounding. If the number to the right is 0 to 4, you round down. If the number is 5 to 9, you round up. That's it.
And this brilliantly illustrates how that works. Applying that rule, the 6 tells us to round up. So the 3 becomes a 4, and everything after it clears out to 0, giving us a nice clean 4,400.
So what does this all mean? Why does this matter? Well, place value is one of the most absolutely crucial concepts in math because it's the foundational engine powering almost everything we do later on. Adding, subtracting, multiplying, dividing, working with decimals, and even counting your money. Literally every single one of these tasks depends entirely on understanding exactly what each digit is worth based on where it sits.
So I want to leave you with one final provocative question to really test what we've covered. Look at this number, 9,421. Based on the architecture we just explored, what is the actual hidden weight of that 9? Once you understand the rules of this system, I promise you'll never look at a simple string of digits the same way again. Thanks for joining me for this explainer, and keep questioning the why behind the numbers.